When you think of general aviation engines, one of the first names that comes to mind is the legendary Pratt & Whitney PT-6A, a staple of small aircraft turbines. But what if I told you there's a different engine technology that could perform similar or outperform it in many areas? Today, we're comparing a theoretical 4.4 ELU Wankel rotary engine capable of producing 1,200 horsepower against the well-known PT-6A turbine engine. Which one is better for general aviation, and why should the Wankel be your engine of choice? The PT-6A by Pratt & Whitney has powered general aviation aircraft for decades. It's reliable, well-known, and packs a punch with 1,200 horsepower. The PT-6A is a free turbine engine, which means it uses separate turbines for the compressor and the power output. This setup allows it to efficiently produce power and drive propellers at lower speeds. But while it has strengths, the PT-6A also has its limitations. One major drawback: cost. Turbine engines like the PT-6A are expensive to manufacture, maintain, and overhaul. Not to mention, they are less fuel efficient at lower altitudes compared to piston and rotary engines. Now, let's take a look at our challenger, the 4.4-liter Wankel rotary engine. The Wankel rotary engine takes a different approach. Instead of complex turbines, gearboxes, and compressors, the Wankel uses a simple rotating rotor inside an oval housing. With far fewer moving parts than a turbine engine, this design results in lower weight, reduced maintenance, and better power density. In our 4.4-liter Wankel configuration, we're looking at a staggering power output of 280 horsepower per liter. That's impressive, considering most piston engines in general aviation typically produce around 50 to 150 horsepower per liter. One of the most critical factors in aircraft design is the power-to-weight ratio. The PT-6A, while powerful, is significantly heavier and bulkier due to its complex design and turbine stages. In contrast, the 4.4-liter Wankel engine is compact and lightweight. By reducing engine weight, you're not just making the aircraft lighter, you're also increasing fuel efficiency, payload capacity, and range. This weight savings can be as much as 30 to 40% compared to the PT-6A. For general aviation, this means you can carry more passengers or cargo and burn less fuel, making every flight more economical. Let's talk about one of the biggest costs in aviation: fuel. Turbine engines like the PT-6A are known for being thirsty, especially at lower altitudes where general aviation planes typically fly. The PT-6A's optimal fuel efficiency kicks in at high altitudes and long-distance cruising, but in general aviation, short hops at lower altitudes are more common. Here's where the Wankel engine shines. The rotary design is more efficient at these lower altitudes, burning less fuel while producing similar power. Over the long term, the savings on fuel alone could make the Wankel engine a much more cost-effective option for general aviation pilots.
While turbine engines are known for their reliability and, while reliable, still have more components that could fail, leading to potentially costly repairs or downtime. Their maintenance and overhaul costs can be eye-watering. The PT-6A requires regular and expensive overhauls due to the complexity of its internal components, from its turbine blades to its gearboxes and compressors. The PT-6A engine is known for its reliability, typically lasting 3,000 to 4,000 hours before a major overhaul. But as with any engine, some parts are more likely to wear out over time. The combustion chamber and turbine blades face extreme heat, so they're prone to wear and cracking. Inspections every 1,800 to 2,000 hours are crucial, costing $15,000 to $30,000 or more for turbine blade replacement. Compressor parts like impellers face high-pressure airflow. Inspections every 1,500 to 2,000 hours help spot damage. Repairs here range from $10,000 to $25,000. Regulating fuel flow, the FCU is a potential failure point. Expect to replace or overhaul it every 2,000 to 3,000 hours, costing $5,000 to $15,000. Pumps, starters, and generators see continuous use, needing service around every 3,000 hours, with costs ranging from $3,000 to $10,000. Critical for smooth operation, Bearing replacements can cost $5,000 to $15,000 and are often done during overhauls. Oil pumps and filters are essential for lubrication, with maintenance costs between $1,000 and $3,000. Finally, a full overhaul costs between $100,000 to $250,000. But regular inspections and preventive maintenance keep these engines performing and save on costs long term. In a Wankel rotary aircraft engine, certain parts are more prone to wear or failure due to the engine's unique design. Let's break down the components from least to most likely to fail. Least likely to fail are the oil control rings. These rings manage the oil film on the rotor housing, preventing oil from entering the combustion chamber. However, if they do fail, they can cause oil burning, leading to performance loss over time. Next are the cooling system components. Wankel engines run hotter than piston engines, and cooling elements like coolant seals and water jackets can wear over time. Overheating here could lead to damage in the rotor housing or seals, but with good maintenance, they remain fairly reliable. Moving up in risk, the eccentric shaft and bearings face high-speed rotation and heavy loads. Overheating or inadequate lubrication could lead to failure, particularly in high-vibration environments like aircraft, making maintenance crucial here. Side seals and corner seals seal the rotor against the housing walls, experiencing constant friction. Any wear on these parts can impact engine efficiency, and they are more vulnerable without proper lubrication. Higher on the list is the rotor housing. This part supports the triangular rotor and is prone to wear due to high friction. A worn or scored housing may require full replacement, impacting compression. Finally, the most likely part to fail, the apex seals. These seals experience the most pressure and temperature extremes, maintaining compression within the combustion chamber. Over time, they can wear, crack, and cause serious issues like compression loss and engine failure, making them the most failure-prone component. Besides the apex seals that are affordable to replace annually for general aviation, where downtime can be costly and inconvenient, the Wankel's reliability can't be overlooked. You're spending less time on the ground with your engine in the shop and more time in the air where it belongs. This means lower maintenance costs, fewer expensive overhauls, and longer service intervals. For private pilots or small flight operations, the savings in maintenance could be the difference between making or breaking the budget. Wankel engines require frequent inspections due to high wear components like apex seals. Typical maintenance costs range from $1,000 to $3,000 annually for routine checks and oil changes. Inspections might include checking compression, cleaning, and small repairs, which help prevent major issues from arising. Apex seals, side seals, and oil seals are common replacement parts. If the engine undergoes significant use or if inspections reveal wear, replacing these parts can cost between $500 and $2,000 depending on parts and labor. Apex seals are typically one of the most significant contributors to recurring maintenance expenses. Wankel engines tend to need major overhauls after 500 and 1,000 hours of use, depending on operating conditions and how well the engine is maintained. Overhaul costs can range between $5,000 and $10,000, but if certain high-cost components need replacing, this figure may increase. Wankel engines may consume more oil than traditional engines due to their design, which uses oil for rotor cooling and seal lubrication. This can add to yearly operating costs, especially for frequent flyers, costing a few $100s annually based on fuel prices and flight hours. For light use, the annual maintenance cost could be around $3,000 to $6,000 for an aircraft Wankel engine. But for heavy use or engines that require more frequent overhauls, it could be $8,000 to $12,000 or more. These estimates also depend on access to specialized parts and labor, as Wankel engines are less common and may incur additional costs for specialized maintenance.
As the aviation industry pushes towards sustainability, engine manufacturers are searching for ways to reduce emissions and increase efficiency. The PT-6A, while a reliable workhorse, doesn't score particularly well in this area due to its higher fuel consumption and emissions at lower altitudes. The Wankel engine, on the other hand, is fuel flexible. It can run on a variety of fuels, including hydrogen and other sustainable alternatives. This flexibility not only reduces emissions, but also prepares general aviation for the future of clean energy. So, with lower weight, better fuel efficiency, reduced maintenance costs, and the ability to run on cleaner fuels, the 4.4-liter Wankel Rotary engine is a compelling alternative to the PT-6A for general aviation. While the PT-6A has its place in high-altitude, long-distance flights, for smaller aircraft that fly shorter routes, the Wankel engine offers advantages that can't be ignored. Whether you're a pilot, a mechanic, or simply an aviation enthusiast, the future of general aviation may well lie in this simple, reliable, and powerful rotary design. Could the Wankel engine be the key to flying further, faster, and more affordably? Only time will tell, but it's a future worth investing in.